Negative feedback loops are inhibitory. They're going to stop something, usually stabilizing a physiological variable by producing an action opposite to what is occurring. We have many inhibitory feedback loops. Usually something is outside of the range and we want to stop that. So if our blood pH is too high, we want to stop that. If we're too acidic, we start hyperventilating to breathe off that CO2, to breathe off that acid. And so it stops that. So think negative, inhibitory. Negative, no. Negative, stop. Positive feedback control systems are stimulatory. The signal gets more and more intense until it produces a major change, oftentimes dramatic, and then we go back to a feedback loop. And so it's stimulatory. It tends to produce extreme destabilizing effects, disrupting homeostasis, and then you go back to balance. Think about if you have a tickle in your nose, or if you sniff too much pepper or something. You know that feeling of you gotta sneeze, the signal's getting harder and harder, then you sneeze and it's extreme. You blow out all of that air very quickly, trying to get stuff out of your nose, then you're back to normal. That's a stimulatory effect. A major one that we use as an example is parturition, birth. And so as contractions occur, contractions get worse and worse, your brain releases oxytocin, those smooth muscles contract, contractions get more and more intense, and eventually you get to a point where there's just no stopping it, the baby comes out in this extreme dramatic event, and then you're done, you're back. So it's a positive feedback loop, it's stimulatory. Usually we stick with the sneezing example and the birth example as stimulatory. All the others that we talk about are usually inhibitory, negative.